Hi, and today we'll have a great, absolutely astonishing theme. It will be about second order derivatives. And frankly, you may see them written like this, or you are able to see them written like this. And you can hear a name, a fancy name, Laplacian, for this kind of product. But don't be afraid. So, I'm pretty much sure you saw a great deal of second derivatives uh, already, and at this time, you're not a novice to them. Because, look, uh, what is a first order derivative first, at the first place? The first order derivative of some distance, like this, with respect to time, is just the speed of the object, or you're able to write it as a s prime. And the second order derivative, here it is, or of some distance with respect to, again, time, it will be just acceleration of the object, or v prime or s double prime. Still, this is kind of an approach which explains what it is, but not completely. We just write this all symbolically, and still it doesn't give a hint of the real understanding what it is. So there is a completely different, I would even say, new way of representation, which I found out for myself really astonishing and juicy, especially in explanation. So let's go to it. Well, imagine we have some function, some coordinate plane, where we have the x-axis and y-axis, and sure we have some numbers like letters, all of the stuff, and we are given with some function, y of x, which equals phi of f of x, some function. So in case we take the second order derivative, we may actually write it as of this kind. It will be f double prime of x. So this is a deal. But what's it actually? Can we represent it numerically, having some numbers in this plane? Like maybe it will be 1 here, 1, 2, 3. Can we really represent with this notion the real function here? Can we find the derivative? Well, it will be quite hard, but there is a completely different approach, as I stated. Look, let's first take the first order derivative of y with respect to x. We may actually write it as a difference or delta of y. Actually, it is. With respect to some coordinate plane. In our case, it's x. So we just take delta of y. Uh, for instance, we may pick up some numbers like y of 3 minus y of 2. Alright, we did a deal with the first order derivative, but the second order derivative, what's it gonna be? It will be just the delta over delta y, like this. Yeah, it will be delta of deltas. So you will kind of, um, how would I say, subtract two different differences. Well, it sounds like a gibberish, but you'll see now. So we take the delta of the some interval of 1 to 2 minus delta of some interval of 2 to 3. So look, what it's gonna be? Well, in case delta y of 3 to 2 was this, look, then delta of 1 to 2 will be the same. So kind of it will be y at 1 minus y of 2 at the position 2. Uh, Minus, we have this minus sign here, so it will be here as well. Minus y at 2 minus y at 3. It was our difference on the interval from 2 to 3. like this, see? And now, when we open the parentheses, we get this equation. So, it will be y at 1 minus y at 2 minus my y at 2 and plus, because minus on minus gives us plus, y at 3. So we'll, overall, in case I write it in a more appealing way, I would say it will look like this. Y at 1 plus y at 3 minus 2 minus twice y at 2. So, and this is the second order derivative. So, frankly, it's like in case you have data of two at 2 points like this and this, some function here, maybe it's strange function, and some data about the middle value, you're always able to find the second order derivative, what is really astonishing to me. Yes, so kind of you take the numbers at the corners and then subtract twice the value at the middle. So let's try it out ourselves. We have some number plane like this, and we have numbers here, here, and here. For instance, there, the y equals to, let it be 5, the function itself. Here y equals to 3, and at this point it's just, let it be 7. Now, what will be the second order derivative of y here with respect to this axis? It's kind of 1, 2, and 3. What do you think? Well, we just pick the numbers. Think about the problem. Pause the video. So I believe you did your deal. So what will be the second order derivative? We just sum the numbers at the ends, like 5 plus 7 minus twice the number in the middle, or 3, what equals to 6. Yeah, awesome. So now we see that so that the second order derivative equals to 6. And in case it was something like the model, quite real model, you could still apply this data. So I hope the video was useful, and see ya in the following videos. Don't forget to subscribe.